Good day, everyone. Our new topic in physics is magnetism. So let us look at what magnetism, like we are done with electricity. You know, the electricity comprises of what? Electrostatics, electric field, capacitor, current, electricity, and electric power and energy. So this is second aspect of it, which is what? Magnetism, or this is the aspect of physics 102. So what is magnetism? The term magnetism is a phenomenon by which magnets exert the attractive or repulsive force on a magnetic material. Phenomenon by which what a magnet exerts its what? Repulsive or attractive force on a magnetic what? Material like iron or nickel or cobalt is called magnetism. So let me write it here. Magnetism. This is the word magnetism. Magnetism is a physical phenomenon by which magnets exert attractive or repulsive force on magnetic material. On magnetic what? Materials like iron, cobalt, or nickel. So the phenomenon by which a physical phenomenon by which magnets magnets exert attractive or repulsive force on a magnetic material like iron, cobalt, or nickel. That is what we call magnetism. So I said the process or phenomenon by which a magnet exert is what? Is repulsive or attractive force on a magnetic material like iron. So this magnet is the one that is what? The point you have a magnet is what? It attracts or repel a magnetic what? Material is what we call magnetism. So this phenomenon is take place in where? In magnetism. It take place in magnet. What is magnet himself? What is magnet himself? Magnet. What's the word magnet himself? Let's look at magnet. So the word magnet is an object or material that produces magnetic field. So this magnet is what? Is an object or a material that produces what? Magnetic what? Magnetic field, which can attract or repel a certain material, like iron. So magnet, this is an object or material that produce a magnetic field. A magnetic what? Field, which can attract or repel certain material, like iron or nickel or cobalt. So any object that can produce magnetic field and is also what repel or attract a certain material like iron, we call it magnet. But the phenomenon in which the magnet exert is what? The attractive or repulsive force on this magnetic material is called magnetism. The phenomenon by which magnet attracts or repel, we call it magnetism. But the magnet himself is any substance that is what? Have ability to what? To produce magnetic field. And can also what? Attract or repel a material like what? Iron and what? And nickel. That is what we call what? Magnet. And look at the magnet. You see here, the magnet can exist in two forms. We have what we call what? Natural, can exist natural or what? Artificial. The artificial magnets are what? Are man-made magnets. So, stop. Magnet can be magnet. Magnet, I said, can be what? Can be natural or artificial. So, what is natural magnet and what is artificial magnet? Check it now. Now, let's start from natural. Natural magnet. Know that anything that can produce magnetic field and have ability to attract or repel ion is called magnet. The phenomenon whereby magnet is being attracted or repel is called magnetism. The magnet can be what? Natural or artificial. Let's check what is natural magnet. The natural magnet occurs naturally. Natural magnets occur now what? Naturally as a pieces of stone. Piece of what? Of stone known as ideal stone. Ideal stone. What is ideal stone? Ideal stone is a dark color oil of iron. A what? Dark what? Color oil of iron. Oil of what? Of iron, which is what? Iron Fe3O4. Yes, of iron. See, natural magnets occur naturally as a piece of what? Of a stone known as what? Ideal stone, or a dark oil of what? Of iron Fe3O4, found naturally. Found what? Naturally. That is natural magnets. So natural magnets occur naturally, and is occur naturally as a piece of what? Of a stone. We call the piece of a stone what? Idle what? Idle stone. This idle stone is what? Is the oil of what? Of iron. Is what? Fe3O4, found naturally. But if it is what? Artificial magnets, at what? Artificial magnets obtain, let me, what? Artificial magnets. These artificial magnets occur by or obtained by rubbing a piece of iron. Let me write it here. This is what? A magnet obtained. A magnet or what? Obtained a magnet what? Obtained by rubbing a piece of iron, a piece of iron, what? Idle stone. A piece of iron, excuse me, with with idle stone, which is what? Magnet, until until it acquire until it acquire what? Acquired the property is similar to that of magnets. That of what? Magnet called idlestone. See, this artificial magnet can be obtained by rubbing of iron with magnet. Assume this green marker is magnet, the black is what? Is iron. It's a magnetic material, but if I want to make this one to be magnet, I'm now trying to what? To rub it with what? To magnet, which is idle stone. So after rubbing, this iron will be what? Magnetized. It will have a property that's similar to the what? To the magnet. And the process is known as artificial. And this process we call artificial what? Magnet. And these artificial magnets can also divided into two. Yes, they can also, the artificial magnet can also divided into what? Into two. What? Number one, and the artificial magnet divided into two. We have what we call temporary magnet, and the second one we have permanent magnets. So those are the what? The two types of what? Artificial magnets we have. So let's take it one after the other. Temporary. So the temporary magnets, they are made from soft iron. Temporary magnets made from soft iron. soft what? Ions or alloy or alloy of or alloy of soft what? Ion, and they can lose magnetism. Mm, they lose magnetism. They lose magnetism. This magnetism is what? Magnetic property. Let me write it. They lose magnetism. Open bracket. And say what? That is magnetic what? Magnetic property. They lose magnetism or magnetic what? Property quickly. Quickly when external source, when external magnetic quickly, and when external external source or is not complete, external magnetic source, external what? Magnetic what? Source is removed. See, temporary magnet is a magnet that acquired by artificial methods of making magnets, and when the magnetic source is being removed from it, their magnetism, which is what? Magnetic property, they will also lose it quickly. Note, if it is acquired the properties by what? By rubbing, abi, immediately, I think this is black is a what? Is magnet. This one is what? Is non-magnetic material. This is iron. Is a material without magnet. So if I rub it with what? With a magnet like this, after some minutes, this what? Green marker will become a magnet. And if it is temporary magnet, immediately I remove the black marker, which is magnet, from it, it will also lose the what? The magnetic what? Property. That is what? Temporary. But if it is permanent, the permanent magnet is what? If you remove the what? The magnetic source from it, it is not, it will not lose its own what? Magnetism what? Quickly. When the source is what? Is being removed. But this temporary magnet, we can use it in, how am I going to put it? In electric bell, dynamo, transformer, and motor, and a relay. Yes, let me add it to it. The temporary. Temporary, they can be used, or they are used in one. We use them in what? In electric bell. Electric what? Bell. We use them in dynamo. We use them in electric bell, dynamo. Let me say yes, relay. And we can also use them in what? In them in relay. We can also use them. Let me add it to this side. Transformer coil. Yes. What? Transformer coil. We can also use them in motor armature. Motor armature. So these are the what? The basic electric device that is used temporary what? Magnet. The next one is Permanent. What is permanent magnet? Permanent magnet. So the permanent magnets are made from a material like a steel. I said this temporary made by material like what? Like iron. This one by material like a what? Like a steel, and retain the magnetism for a long time. They what? Made from material like steel. Like what? A steel, and retain magnetic or magnetic retain magnetism, which is magnetic property, for long time. Temporary magnets, they cannot retain their magnetic property for long time, but permanent magnets, they retain the magnetic property for long time. Both of them are artificial. Immediately you make them by man-made, this one can retain it behaves like it can retain its magnetic property for long time. This can retain its magnetic property for what? For short time. And so what? The magnetic property is what? Will remove or from it quickly. But this one is not remove quickly. And we can use this magnetic what? Permanent magnet. We can use it in telephone earpiece. When I add here the iPod, so we can use permanent magnet in what? Telephone, phone what? Earpiece. And we can also use in what? In a radio loudspeaker. In what? Radio loud what? Speaker. Then we can also use it in what? In electric motor. Electric what? Motor. So we can also use it in what? In dynamo. Dynamo what? Dynamo. So that is all about what? The magnet. Magnet is a substance or a material that can attract or repel magnetic material like what? Like iron, and it also produces magnetic field. And the phenomenon is a physical phenomenon in which the magnet exerts the attractive or repulsive force to a magnetic material is called magnetism. The magnet can be natural or artificial. The natural occurred naturally as a piece of what? A dark stone of iron ore of F3O4 called hydrostone. So the magnet, they occur naturally as a like a dark what? Stone, which is known as what? Iron ore. The artificial magnet, but it can be obtained by rubbing a magnetic material like iron with magnet, with a natural what? Magnet. So that is the artificial magnet. And the artificial magnet can divide into two parts, temporary and permanent. The artificial that is lose its magnetic property easily after achieving the magnetic property, it will lose it easily, is called temporary. But the artificial magnet, which is not lose its own magnetic property easily, or it will retain it for the long time, we call it what? Permanent magnet. So the next thing that I'm going to treat under magnet now is what? Magnetic pole. Magnetic what? Magnetic pole. Magnetic what? Pole. Look at the magnetic pole. Every magnet has two poles, North Pole and South Pole. Every magnet has what? Two poles, North Pole or what? Two poles. There is no magnet that has what? Just one pole. Monopole does not exist in what? In magnets. So every what? Magnetic pole, let me say every magnet, every what? Magnet has two poles called north N and south X. And this pole, like what? Let me add it. Like pole, like what? Pole, repair. And unlike pole, unlike what? Unlike pole, attracts. So I said magnetic pole, every pole has what? North and south. See it? If you have a magnetic bar in this form, so magnets can also exist in two forms. We have in bar, in suaux, and in this form. So the magnet we have here, this one, yes, this end here is north. This place is what? Is south. So if I want to name this now, I call it what? This is what? North pole. This is what? South pole. And this structure itself, we call it what? Bar magnet. I call it what? Bar magnet. But if you have a magnet in this form, we have some magnets that have this kind of what? Of structure. So if magnets have what? This kind of structure, the magnet, we call it horseshoe magnet. Horseshoe magnet. And this side is north, this place is what? Is south. So here we call it what? North pole. Here we call it what? South pole. And the another form of magnet, the magnet can also exist in this form in circular disc. Can you see it? This one will be what? It's flat. It's circle and it's what? It's flat. So we call this one what? Disc magnet. Disc what? Magnet. And here, you know, for every disc, it will have what? Top and what? Head. This is top, head, and it has base at the back, Abi. So the head here, the head on top here of this, we call it what? North pole. At the other side here, at the back of this end, we will have what? South pole. It's just like a what? A coin. Coin has two heads. It has two coin has two parts, head and what and tail. So the part of the disc up here is called north. The part at the what the other side we call it was south pole. So these are the three types of magnet what we have. Just know that is what a magnet can never have what one pole. Monopole does not exist in what? In magnet. Please note it. Mono what? Monopole. Mono means what? One. So for every magnet, we have what? Two pole. Because if I cut this bar magnet, assume if I cut it into what? Into two, like this, or if I cut it into three, like this, abi. So every end here, this is still what? North, south, north, south, north, south. And if I continue what? Cutting. If I still cut this one to what? Into two. I cut this into two. Continue cutting the what? The bar magnet is to continue give you north, south, north, south. You can never have a magnet of a single pole. That is magnetic what? Magnetic pole. So let's move to the what? The magnetization, which is what? The method of making magnets by artificial. How are you going to what? If this is iron and is non-magnetic material, I want to make it to become a magnet material. So the process of making non-magnetic material a magnet, we call it what? Magnetization.